This will be the commencement of our first final exam review for our college algebra class, and we're going to work through them in 10 to 12-minute increments and go through question by question. I've spread out these questions so they don't follow a chronology, so hopefully you can use this as a mechanism in which you've already started and you've prepared for your final exam, and now we're going to be able to work through questions, not having that chronology to back you up, not knowing that you're going from 2.1 to 2.2, 2.2 to 2.3, and so forth. You're able to look at a question and immediately recognize what tools that you know you're going to have to use in order to solve these questions. So what I recommend doing is try pausing between each question. So maybe now pause, see if you can go ahead and do this question, then use my work to go through and confirm your correct solution. So with this first question, we're going to have the following function. We need to find f of negative 2x. So we're going to find f of negative 2x. So everywhere we have an x in f, we're going to plug in negative 2x. So we're going to have 7 times negative 2x minus the square root of negative 2x to the fourth minus 2 times negative 2x. And this is all underneath the radical sign. So f of negative 2x will equal to 7 times negative 2x gives you negative 14x minus the square root. Be careful here. When you raise negative 2x quantity to the fourth, you're going to have to raise negative 2 to the fourth. Excuse me. And x to the fourth. So negative 2 to the fourth will give you a power that is 16. Will give you a value that is 16x to the fourth minus 2 times negative 2x gives you a positive 4x. So we're going to have negative, oh, that's not so nice. So we'll have negative, positive 16x to the fourth plus 4x. But we can go ahead and clean this up a little bit and factor out a GCF. So here we're going to have f of negative 2x is equal to negative 14x minus the square root. I can factor out a GCF here, which is a value of 4x. So I'll have 4x times 4x cubed plus 1. So now we can split these radicals up, because if we know that we have the nth root of a times b, that gives you the nth root of a times the nth root of b. So as we said, we can split up the radical because the nth root of ab will be equal to the nth root of a times the nth root of b. So in this circumstance, we can split up this 4x and the 4x cubed plus 1 into two independent radicals. So this can be the square root of 4x times the square root of 4x cubed plus 1 all underneath the radical. So here we can say this is a value of 2, negative 2, because we'll have negative square root of 4 times, remember, square root of 4x would be equal to square root of 4 times the square root of x. So this is just going to give you a value of 2 root x. So we'll have 2 root x times the square root of 4x cubed plus 1, and we can go ahead and distribute this x through, and we will get x times 4x cubed plus 1. Moving on to f of negative 1. In this circumstance, everywhere we see an x, we're going to plug in a value of negative 1, so we'll have negative 1 equaling to 7 times negative 1 minus the square root of negative 1 to the fourth minus 2 times negative 1. Simplifying this, we will have a negative 7 out in front minus the fourth power of negative 1. Well, negative 1 to the fourth power gives you a value of positive 1. Negative 2 times negative 1 gives you a value of positive 2. So this will be negative 7 minus square root of 3. And that'll be your solution. And f of t is actually relatively nice, because everywhere we see an x, all we're going to have to do is plug in a value of t. So we will have 7 times t minus the square root of t to the fourth minus 2t. And that concludes number 1. So in this question, we're going to have to determine the domain of each one of these functions. The question asks you to find the domain of each one of these functions. So in order for us to find the domain of each one of these functions, we have to look at them independently and recognize what type of functions they are. So if we look at f of x, we recognize that f of x is a rational function. is a rational function. So this function has an opportunity to have an undefined point, a place that causes the numerator to equal to the denominator to equal a value of 0. So if we ever have a 0 in the denominator, we know this function is undefined and therefore does not exist, and our domain does not exist at that value as well. So in order to find the domain of f of x, we're going to set 2x squared plus x minus 3 not equal to 0. We can solve this using two different mechanisms. The first we can factor, or the second we can use the quadratic formula. I like to factor. So we're going to take 2 times 3, which gives you a value of 6. So we define values of the factors of 6, which add together to give you a positive 1. 1 and 6 will not give you a positive 1. However, 2 and 3 can give you a positive 1, and that will be in the fashion of a negative 2 and a positive 3. So we're going to substitute those values back in. So we're going to have 2x squared plus 3x minus 2x minus 3 set equal to 0. So notice here, all I did was substitute those values in, and notice 3x minus 2x still gives you a value of positive x. So we haven't changed our problem, we just changed the way it looked. So now since we have these 4 terms, we can factor this by grouping, making sure to watch out for that negative in front of that 2x. You have to be careful about that negative in front of the 2x. So we can factor out a common factor from our first group. Notice that will be a value of 2x. We're going to be left with a value of x plus 3. And here we have to factor out a value of negative 2, and that will give us another value of x plus 3. And this is still set equal to 0. So in this circumstance, we can factor out the x plus 3's. And then we're going to be left with 2x minus 2. And again, this should have said not equal to 0 because we have to exclude these values from our domain. So here we can say x plus 3 cannot equal to 0. And we can set 2x minus 2 not equal to 0. So x cannot equal to negative 3, and x cannot equal to positive 1. Remember, we solved this. 2x minus 2 cannot equal to 0. Add 2 on both sides. So we get 2x cannot equal to 2. Divide both sides by 2. X cannot equal to a value of 1. So we could write this domain in set notation as x such that x cannot equal to 1 or 3. If you want to write this in interval notation, you would start at negative infinity and continue on to negative 3. We're going to have to union this with negative 3 all the way to positive 1, and then we union this from 1 to positive infinity. We cannot include these values because of these values you have a function that does not exist. So notice with g of x we have the square root of 4x plus 1. So our g of x is equal to the square root of 4x plus 1. So here we have to recognize that we have a radical equation. So we should be thinking something to ourselves is we should be thinking, what is that index? Remember, if the index is even, we have something to worry about. If the index is odd, it's not so bad. So in this circumstance, let me get my eraser. In this circumstance, we have an index of square roots. So even though we don't see that index, we know it to be a value of 2. Therefore, if we have an index of the radical that is even, we know the radicand must always be greater than or equal to 0. The radicand must always be positive. Therefore, we know 4x plus 1 must be greater than or equal to 0 because we can only take the square root of a positive value or 0. We're going to solve this by subtracting 1 on both sides. And we're going to have 4x must be greater than or equal to negative 1, dividing both sides by 4. And we get x must be greater than or equal to 1/4. We can write this in set notation as x such that x must be greater than or equal to 1/4. Or interval notation, negative infinity to 1/4, union 1/4 to infinity. So we can write it in such a fashion like that. So this would be part B. And this right here was part A. This right here is part A. And lastly, we can look at h of x. So notice we have the fifth root of x squared minus x minus 1. So I'll do that over here. So we have, this was, what was that? H of x. We have the fifth root of x squared minus x minus 1. So this problem differs from the one prior in the fact that the radical's index in this circumstance is an odd value. And remember, when we have an odd index, we can take the root of both a positive and a negative value. In the circumstance of having an even index, we know that we can only take that root of a positive value. We cannot take it if it's negative. But in the fifth, if we have the fifth root, the seventh root, the third root, the 13th root, the 121st root, those are all odd indices, and we can take the fifth root or the third root or the seventh root or the 123rd root of both negative and positive values. Since we can do that, we know that the domain of this guy is going to be all real numbers, which we can also write in interval notation from negative infinity to positive infinity. So if you have any questions about this one, go back and review domains of rational functions and radical functions and polynomials. So go back and review domains of rationals, radicals, and polynomials. And that will help you review what to expect for with your final exam when it comes to how to identify domains.